in last?
Yeah, we did 2 questions.
Which one? The last question.
A charge Q is placed at a separate distance on Q2 from the center of a square of each side A. Calculate the flux, then the square. Add 5 more squares.
Give me a second, please. A charge Q is placed at the center of hemisphere. Calculate flux to a hemisphere. This is the question last. This is last question.
No, that's the second last.
Okay, it's the second last. What is the last?
A charge Q is placed at a separation on Q by 2 from the center of the
Not
square.
Q by 2, it is A by 2 from the center of a square of each side A. Okay, as shown in figure, calculate flux to a square, right? This is your question?
Yes.
Okay, all right. Okay, this is a not Q by 2, it is A by 2. Okay. Now we are going to solve it. We are going to solve it. Suppose that this is a surface.
We already solved it.
Sorry? Okay, we have already solved it.
Yeah.
Okay. I mean, both of the question is solved, right?
Yes, sir.
Okay, good. And now we are going to solve, and now we are coming on the next point. Please note it down. A right circular cylinder is placed with its center at the origin and axis along positive x and axis along positive x-axis calculate total flux through the cylinder. Charge in through the cylinder, charge, calculate total flux through the cylinder charge enclosed by the cylinder. Okay, this is your question. Note it down, please. Hello, hi Matthew.
Hi, sir.
Yeah, note it down, please. Then we will try to solve
Noted,
it.
sir. Noted. Noted.
Nawal, it's noted or not?
Yes, sir.
Okay, good. Now it is saying that a right circular cylinder is placed with its center at the origin and axis along positive x-axis. Okay, I mean your cylinder is placed along the positive x-axis. Are you clear? So if you want to draw the diagram of this, then you can look at here. This is your cylinder. Suppose that this is your cylinder. This is your cylinder. Okay. And according to this cylinder, according to the question, this cylinder is placed in such a way that the origin center at the origin. Okay. Suppose that if you draw the coordinate system, then we can look at here. This is your plus x-axis. And this one is your plus y-axis. The third one is your z-axis. All right. If we place this coordinate frame at the center of the cylinder, then we can say that the center of the cylinder is at origin. Please try to understand your given question. A right circular cylinder is placed with its center at the origin. Are you understand it or not? With its center at the origin. Okay. Now we can say that this is your center of the cylinder, which is placed as at the origin. If it is at origin, then we can write here 0, 0. Okay. Are you understand it? And now the length of the cylinder is, suppose that the length of your cylinder is L. This is your length of the cylinder. 1 second. This is your length of the cylinder. And we can say that if this is the length of the cylinder, then half length of the cylinder will be L by 2 and the another half will be also L by 2. Are you clear? If this is your L, then the half part of the cylinder is L by 2 and the half part and the other half part is L by 2. Are you clear? And now, can you tell me, this is your y-axis, then we can say the right part of the y-axis can be considered as x is greater than 0. X is greater than 0 and the left part of x-axis is x is less than 0. Are you clear? Then the electric field along plus x-axis is E is equal to, suppose that your electric field is E naught, then we can write here E naught I cap, and the left side part and the left side of the field is E naught minus of I cap. Okay. Are you clear till here? And now, can you tell me how many surfaces are available here? We can consider a total 3 surfaces. This is your surface 1, and this is your of surface 2, and this is the surface number 3. This is your surface number 3. Are you understand? How many surfaces are there? There are total 3 surfaces, in which the 2 of the surfaces are cross-sectional area, and the one of the surface is the total side area of the cylinder. Let the radius of the cylinder is r, then we can also consider that the radius is uniform here. And now this is your x-axis, I mean plus of x-axis, and the left one is your minus of x-axis. Okay. Are you clear? We are going to solve for your cross-sectional area 1 first. Okay. We have already know for end 1. For end 1, what will be your flux? The flux is your phi is equal to E dot S. 1 second. E dot S. What is the E? E is your E naught minus of I cap, and area is your pi r square, because this is your cross-sectional area. So it is pi r square in the direction of minus I cap. After solving, you get the value of phi is E naught pi r square. E naught pi r square. This is your equation number 1. Similarly, if we go to solve for the cross-sectional area of end 2, then your phi 2 will be no, it is your cross-sectional area 3. Actually, we have taken make it 2. Okay, and this is your order first, 2 and 1. Okay, sorry, not 1. It is your 3. So it is your phi of 2 will be E dot S. What is your E? E is your E naught for the surface of 2. E is your E naught I cap into what is your S? S is your pi r square, and the direction is plus I. So we can write here once again I cap. After solving, you get phi 2 is E naught pi r square. Are you understand it or not? Hello?
Yes,
Yes.
sir.
All of you are understanding?
Yes.
Okay, good. Similarly, if we try to solve for your curved surface, please note it down, then we will go to the, okay, on the last part. Note it down, please. All of you have noted it.
Yes, sir.
Can we move on?
Yes.
Okay. And now the last part is for your curved surface area. Suppose that you are taking some curved surface area. Then you can look at the diagram first. Electric field. Yeah. The electric field is along the direction of plus x-axis, and the field line when start to pass from the surfaces, then it always be perpendicular to the surface from this surface. Are you clear or not? From this you can look at here the angle between the electric field and the electric field lines, okay, is making the angle between the unit vector, this is your unit vector as well, and this is your electric field lines also passes. So the angle between the area vector or surface vector, you can say also, and the electric field are making 90 degree with each other. Are you clear? So we can write here for your end 3, for your end 3, your phi 3 is E dot S cos of 90 degree. We can write cos 90. What is your cos 90? Cos 90 is 0. Okay. Your cos 90 is 0. So the whole value of your phi 3 is also 0. Note it down. Note it down, please. Have you noted it?
Yes.
And now, what is the total flux? Total flux. Your total flux phi is equal to phi 1 plus phi 2 plus phi 3. What is your value of phi 1? Phi 1 is your E naught. Phi 1 is E naught. Sorry, it's not working due to the heat. E naught pi r square plus phi 2 is also same value, E naught pi r square. And the last one, phi 3 is 0. Finally, you get 2 E naught pi r square. Okay, 2 E naught pi r square. And now, what is the amount of charge enclosed by the cylinder? To calculate, we can write down here the total charge enclosed this is your phi is equal to Q over epsilon naught. We can also write Q is equal to 5 epsilon naught. And finally, we get what is your value of phi. Phi is your 2 pi epsilon naught. 2 pi epsilon naught r square into 2 pi, 1 second, sorry, 2 epsilon naught pi r square into E naught. Okay, note it down. Note it down, please. This is your amount of charge enclosed within the cylinder.
Done.
Have you noted it?
Yes, sir.
Okay. Nawal, have you noted it?
Yes.
Okay, good. Next one is application of Gauss law. Application of Gauss law. This is your next heading. Please note it down. Application of Gauss law. Okay. We, all of us, are knowing about the equation of the Gauss law. First, I am going to write it. The calculation of electric field due to symmetrical charge distribution. Electric field due to symmetrical charge distribution is integration of E dot ds is equal to Q over epsilon naught. Okay. This is your general formula to calculate the flux or field. Okay. And now, what are the conditions which is required for the Gaussian surface? Note it down, please, about Gaussian surface. What are the Gaussian surface? Okay. So please note it down, your criteria. Criteria to choose Gaussian surface. Criteria to choose Gaussian surface. The first one is the surface should be closed. The surface should be closed. This is, if the surface is closed, then your formula is integration of E dot ds is equal to Q over epsilon naught. Q over epsilon naught. The second condition is E is in the sense electric field is parallel or perpendicular to area vector. Okay. The formula is integration of E dot ds cos theta. E dot ds cos theta. Your theta is 0, which is your Q over epsilon naught. And if your E dot ds cos theta, where cos theta is 90 degree, then your value is 0. Why? Because we have already know cos 90 is 0 here. Okay. The last point is E. E in the sense electric field should be uniform. Electric field should be uniform throughout Gaussian surface. Throughout Gaussian surface. The formula is, if the field is uniform, then you can write as your electric field is a constant term, which you can take outside from your integral. Integration of ds is equal to q over epsilon naught. Note it down, please. Have you noted it or not?
Not it, sir.
Okay, good. The next is types of Gaussian surface. Types of Gaussian surface. How many type of Gaussian surfaces are possible? The first one is spherical. Second one is cylindrical. Second one is cylindrical. And the third type is Gaussian pillbox. You can write it like a cuboid. Okay. You can also consider it as cuboid. Your cuboid is also known as Gaussian pillbox. Gaussian pillbox. Okay. These are the three types of Gaussian surfaces which are mostly used in our syllabus. Are you clear or not? But it is also remember that there is no any condition or there is no any rule, okay, which tells you that your Gaussian surface is any particular type. Okay, it may be any of the type. Okay, it doesn't matter, but the only and only condition is that your Gaussian surface always be closed. Are you clear or not? Your Gaussian surface always be closed. Okay, this is the necessary condition of your Gaussian surface. Note it down, please. And now we are going to calculate the electric field due to infinite line charge. Have you noted it?
Yeah.
Good. Electric field due to infinite line charge, or you can also say infinite line charge or due to infinite wire. Sometimes it is also said to be the wire, or you can also consider as a rod. Note it down, please. This is your heading. Okay. And now we are going to draw the diagram first. Suppose that this is your line charge, which we are taken here. This is your line charge. Okay. If it is your line charge, then we can draw here. These are the positive charges which are placed at this line here. Okay. And now, first of all, to calculate the electric field, we required the Gaussian surface. If we draw the Gaussian surface, then you can easily understand that the Gaussian surface should be symmetrical to the given body. This is your Gaussian surface which we are taking for this infinitely long rod, and this part should be like this, and this is your of like this. Okay, this is your Gaussian surface. We can consider that the Gaussian surface is of radius r. We can consider Gaussian surface is of radius r. And now, suppose that this is your surface 1, and this is your of surface 2, and this one is your surface of 3. Okay. What will be the area vector? First of all, we are going to draw the electric field lines due to this line charge. You have already known the electric field lines always be drawn perpendicular to the surface. If you draw these field lines perpendicular to the surface, then you can look at here. These are the field lines. Okay. Okay. These are the field lines which are passing perpendicular to the Gaussian surface. You can understand. These are making 90 degrees. Okay. The area vector for this surface will be along the direction of the field. This is your area vector, you can say, or electric, or you can also say unit vector. The electric field lines is also in the same direction, which making the 0 degree angle with your surface. And now the area vector for this cross for the surface of 1 is your perpendicular to the surface, because we have already know. And the area vector for the surface 3 is also perpendicular to the surface. It also makes 90 degrees. Okay. Then we are going to calculate the flux. We are going to calculate the flux. First, we are going to calculate the flux of surface 1. Flux through and 1. It will be phi 1 is equal to E dot S, which is your ES. The angle between E and S is 90 degree. We can write here cos of 90, which is 0, because cos 90 is 0. Similarly, flux through and 2. It is your phi of 2 is Es cos of, for your surface number 2, the field lines is in this direction and the surface vector is perpendicular to the field line. So we can write here E dot S cos 90 degree again. Once again, we get 0. Like this, flux through surface 3, or you can say flux through curved surface. This curved surface is your phi 3 is equal to E dot S cos of 0. What is the value of E here? E can be written as E, similar, okay, as it is. And the curved surface area is 2 pi R L. Remember here, your S is 2 pi R L for cylindrical surface especially. This is your phi 3. Now, what is your total flux? What is your total flux? It is your phi 1 plus phi 2 plus of phi 3. What is the phi 1? Phi 1 is 0, phi 2 is 0, and phi 3 is E 2 pi RL. Finally, you got, one second. Finally, you got phi is equal to, one second, please. Yeah, finally, you got phi is equal to E into 2 pi RL. E into 2 pi RL. Okay, this is a total flux through this Gaussian surface, which is passing through this Gaussian surface especially. Okay, and now anyone can tell me that which type of density is available here. It is your linear charge density because your given body is in length only. So we can write here now we have no lambda is equal to Q over L. So we can write here lambda is equal to Q over L, or we can write Q is equal to lambda into L. Okay, what is your value of Q here? One second. One second, just 1 second, give me. Now phi is equal to Q over epsilon naught. So we can put here value of phi E into 2 pi RL is equal to Q over epsilon naught. Q over epsilon naught. And now we have lambda is equal to Q over L, or Q is equal to lambda into L. Okay, put this value at the place of Q. It will be E into 2 pi RL is equal to your value of Q is lambda into L over epsilon naught. Lambda is cancelled with, L is cancelled with L. You get E is equal to lambda over 2 pi epsilon naught R. Note it down, please. Note it down, please. Nawal and Matthew, all of you have understand it or not?
Understood.
Okay,
Sir, understood.
good. Note it down, please. Have you noted it?
Yes.
Good. And now we have an equation which is E is equal to lambda over 2 pi epsilon naught. Sorry, 2 pi R epsilon naught. Okay. This is your final equation which we have calculated. From this equation, you can also observe that E is directly proportional to 1 over R. E is directly proportional to 1 over R. This means what is the relation between the R and E? What is your R? R is your radius of the Gaussian surface. Okay. If you want to draw the diagram, if you want to draw the graph between E and R, then You can write here. It will be like this. Okay. Note it down, please. This is your R and this is your E. Also note it. Now, please note it down, a question here. We have two line charges like this. These are the two line charges. The first line charge is positive in nature. And the second one is of negative in nature. Okay. There is a center between these charges, O. The separation from both of the line charge to the center O is A. This is your A and this one is also A. Okay. Then what is the separation between both of the line charge? Total separation, it is 2A. Suppose the line charge density, or you can say the charge density on this is your lambda 1, and on the second line charge it is lambda 2. It is saying that calculate electric field at O. This is your question. All right. Now we are going to calculate. What is the net field at O? I think the net field at O will be, the net field at O is E is equal to, I mean electric field, the total electric field is electric field due to the positive line charge and electric field due to the negative line charge. Okay. Then can you tell me what will be the direction of the field due to this positive line charge at point O? Can you tell me? I think the electric field lines always passes so this point along away direction. Why? Because this is the positive line charge. Are you clear or not? And we have already know positive charges. I mean electric field lines from positive charges always go away from the charge. Are you understand it or not? So due to this positive line charge, your electric field, the direction of your electric field at the point O will be also in away direction. So we can write here, we have already calculated the value, the final equation, which we are taking directly without any calculation. It is your lambda over 2 pi epsilon naught A. Your separation is A, not R here. So we are taking A plus. And now due to the lambda 2, the direction of the electric field will always be towards the charge. It is also towards the charge. So we can write here, just 1 second. If we go to write the direction for the lambda 1, so you can write here I cap. And for E negative, it is also lambda over 2 pi epsilon naught A I cap. I mean, both of the fields are in same direction. Okay. So what will be the final value? You can look at lambda over 2 pi epsilon naught a can be, sorry, it is your lambda 1, it is your lambda 2. 1 over 2 pi epsilon naught a can be taken as common, and this is your, in bracket we can write, it is your lambda 1 and lambda 2. Okay, this is your final answer, which is the field at this center. Are you clear or not? Hello,
Yes,
are you
sir.
understand or not? Nawal, are you understanding?
Yes. Sir.
Okay, good, good. Note it down. Note it down, please. It is very easy question. Okay. Can we move on?
Yes, sir.
Okay. Electric field due to infinite plane sheet. Electric field due to infinite plane sheet. Okay. We are taking an infinite plane sheet. I mean, the size of the sheet is infinite. Okay. This is of your positive charge sheet. This is your positive charge sheet. Okay. I mean, the size of the sheet is of infinite. You can consider as all of the sides are infinite here. Okay. And now it is saying that we are going to calculate the electric field due to this sheet. Okay. Then anyone can tell me what is the condition first? First of all, we should choose a Gaussian surface. Am I right or not? First of all, we are going to choose a Gaussian surface. Okay. Now, suppose that this is a infinite sheet of charge, then what will be the direction of the electric field in the right way, or in the x-axis, you can say also. So the direction will be along x-axis, and in the left part, the direction will be along this. Are you understand or not? Hello? All of you are understanding or not?
Yeah.
Yes.
Okay, good. And now, first of all, we are going to choose a Gaussian surface first. Suppose that we are taking this small portion of this sheet, and with respect to this, we will calculate your electric field. These both areas are same here. These are the area S. And now the unit vector will be along this direction from both of the sides. These are the unit vectors. And electric field you have already know in this case. Now we are going to solve it. Consider a cylindrical Gaussian surface. Consider a cylindrical Gaussian surface having area of ends S. Then what will be the flux through end 1? Can you tell me? This is your end 1 and this is your end 2. The phi 1 will be equal to the E dot S cos of 0. The angle between the unit or area vector and the electric field is 0 here. So E dot S cos 0. And if cos is 0, then your flux will be E dot S. This is the equation number 1. Similarly, your flux through end 2. This is your phi 2, which is Es cos of 0 again, which is E dot S. Okay. The third one is, this is your surface. Then flux through curved surface. Flux through curved surface will be phi 3, which is equal to Es cos of 90 degree. Okay, this is your equation number 3. Or if your cos theta is 90, then final value will be 0. Then what is the total flux through this Gaussian surface? Your total flux will be phi is equal to phi 1, phi 2, and of phi 3. Phi 1 and phi 2. Please note it down first. 1 second. What is your phi 1? Phi 1 is your Es. Phi 2 is also Es plus 0. It will be phi is equal to 2 Es. What is the value of E? First of all, note it down here. Please note it down. Have you noted it or not?
Yes, sir.
Can we move on? Matthew? Hello, Matthew?
Yes, sir. Yes, sir.
Yeah, okay. And now we have phi is equal to 2es. Remember that. We have phi is equal to 2es. Okay. And now suppose that we have already, this is your surface. This is a surface type body. Okay. Then the amount of charge present upon this surface is said to be the surface charge density. Can we say it or not? Hence, we can write here your surface charge density is Q. I mean charge enclosed. First of all, I am going to write Q is phi is equal to Q over S, or Q is equal to phi into S. Okay. What is your one second? What is your phi here? Phi is your 2es is equal to Q over S. Okay. And we have already know the surface charge right here at the same place here. Surface charge density. Your surface charge density, which is denoted by sigma Q over S, or we can also write Q is equal to sigma into S. If we place this value of Q at this position, you get 2es is equal to sigma S over S. S is cancelled with S. You got E is equal to sigma over 2S. Just 1 second, please. Don't note it. Give me a second, please. You enclose this sigma into S, okay. And when we place the value of phi, sigma S over epsilon naught. Where is epsilon naught? Just 1 second. 1 second. Give me a second, please. This is a phi is equal to Q over epsilon naught. Remember here, this is a mistake here. Q over epsilon naught. 1 second. Phi is equal to Q over epsilon naught. When you put this value, 2es is equal to Q over epsilon naught. And now we can place here Q is equal to sigma into S. When you put in this, you get 2es is equal to sigma S over epsilon naught. Sigma 2es is sigma S. S is cancelled with S. Finally, E is equal to sigma over 2 epsilon naught. Okay. Yeah, there was a mistake only epsilon naught. Okay. Note it down, please. Now it is correct. Your electric field due to this sheet is sigma over 2 epsilon. Note it down, please.
Hello, welcome to the.
And now you can also look in this. This electric field is independent of R. Okay. This is your independent on independent of R. If it is independent of R, then we can also say It is your uniform field. Okay. If it is uniform, then what will be the diagram? The diagram will be like this. Note it down, please. Please note it down. Are you understanding? Nawal,
Yes, sir.
Matthew, are you understanding or not?
Yes, sir.
Good. Have you noted it?
Yes,
Can we
sir.
move on?
Yes,
Okay,
sir.
good. Now we are going to take a question here based upon this heading. We are taking two infinite sheet charge. We are taking two infinite sheet of charge. Okay. This is your positively charged sheet. And this is the negatively charged sheet. Okay. And the region is this your first region. And this is your second region. And this one is the third region. In question, it is saying that calculate the field, calculate electric field in region 1, 2, and 3. Note it down, please. Then we will try to solve. Have you noted it? Hello?
Yes, sir.
Have you noted it? Matthew,
Yes, sir. Noted.
all of you can solve it or not?
Sir, can you solve?
Okay. See on the screen. The one of the important point which is used to solve this question is the direction of field lines due to positive charge always be away from the charge, and due to negative it always be towards the charge. Are you understand it or not? Do you remember?
Yes, sir.
Okay. Now if I take a point here, can you tell me at this point, suppose that this is your point in region 1, we can say, what will be the direction? This is your plane sheet of 1 and this is your plane sheet of 2. Okay. Can you tell me what will be the direction of the field due to the positive plane sheet?
You'll go
Due
away
to
from the
positive
field.
plane sheet, it always be in away direction. Am I right or not?
Yes, sir.
Okay. And what will be the direction of positive charge plate sheet in region 2?
It'll be
In
towards the
region 2,
negative charge field.
we can also say it is always away from the positive charge. Are you understand, Nawal?
Yes, sir.
And in region 3, what is the direction here? It once again away from the charge. Are you understand or not? Hello?
Yes, sir.
Yes,
Just
sir.
try to understand here. If we are drawing the electric field of positive charge sheet, then no need to see the negative charge here. Okay? Only concentrate on the positive charge sheet, not on the negative charge sheet. Okay? Are you clear?
Yes, sir.
Yes, sir.
So we can say the field lines due to positive sheet of charge always be away from the charge. Are you clear? So we can write here, this is your E1. This is your direction of E1. This is your direction of E1. Are you clear or not? Similarly, what will be the direction of field due to negative charge in region 3? Any one of you? What will be the direction of electric field due to negative sheet in region 3? It always be towards the charge. Are you understand? Are you understand or not?
Yes, sir.
And in region 2, it once again towards the charge. Then what is the direction of towards? This is your towards direction. Are you clear? Hello? Nawal, are you understanding?
Yes, sir.
Once again, in region 1, what is the direction of towards? It once again along this direction. Now, all of you can write here. This is your E2. This is your E2. Are you clear or not?
Yes, sir.
Okay. And now the next point, which is important here to understand, can you tell me in region 1, E1 will be strong or E2? Which one is stronger, E1 or E2? Which one field is stronger, E1 or E2? I think E1 is stronger in region 1 as compared to E2. Why? Because the positive charge sheet is closer to this point. Are you clear?
Yes, sir.
Positive, just 1 second. Make it positive here. 1 second. I am changing the notations here. Make it positive just for understanding. Okay, fast. Make it positive and make it negative. At the position of 2, you can write here negative. Okay, make it negative, E negative. Are you understand right now? Hello? All of
Yes,
you
sir.
understanding right now?
Yes.
Okay. then E positive, the magnitude of E positive is greater as compared to the E negative in region 1. And which one is stronger? E1 or E minus or E plus in region 2? I think E1 and E2 both are same. Am I right? Am I right or not? Why? The separation from both of the sheet is same. In region 3 is closer to the negative charge. So E minus is greater as compared to E plus. All right. Now we are going to calculate for region 1, E1. What is your E1? Which one is greater? Which one is greater? You can write here E plus and plus of E minus here, which is, what is your E plus? We have already know the plane sheet charge equation here. Sorry, your equation is sigma over 2 pi epsilon naught. Do you remember or not? Do you remember or not? And what is the direction of E plus? E plus direction is along negative x axis, or you can also say negative I cap. Make it, write down also it, plus E minus is sigma over 2 pi epsilon naught. This is your I cap. Finally, after calculation, you can take I cap over 2 epsilon naught in bracket sigma minus, this is your sigma 1 especially, this is your sigma 2. You can take sigma 2 minus sigma 1 after calculation. This is your electric field in region 1. Are you clear? Hello?
Yes, sir.
All of you understanding? Similarly, in region 2, your E plus and E minus, both are lying in the same direction. So we can put here sigma 1 over 2 epsilon naught I cap, which is your plus. Why? Because the direction is along plus x-axis, plus of sigma 2 over 2 epsilon naught. This is also in plus I cap. Finally, after calculation, you get I cap over 2 epsilon naught in bracket sigma 1 plus sigma 2. This is your E of 2. Are you clear here? This equation is clear.
Yes, sir.
The last region is E3. What is your E3? E3 is your, which one is greater here? I think E minus is greater. So we are taking E plus, E of minus. What is your E plus, direction of E plus? You can take sigma 1 over 2 epsilon naught. E plus is along plus x-axis. So we can write here I cap only, plus sigma 2 over 2 epsilon naught. The direction of E minus is along minus of I axis. We can write down here I cap over 2 epsilon naught in bracket sigma 1 minus sigma 2. Are you understand? This is your
Yes,
E3. Note it down, please, fast. Matthew, are you clear?
Yes, sir.
Any issue?
No, sir.
I think it was very, very easy question. Am I right?
Yes, sir. Yes, sir. I understand.
Okay, good. Note it down, please.